Hello friends, in our last video lecture we have discussed delta modulation transmitter and receiver, and we have discussed that in DM there are two types of quantization error. First is called slope overload error and second is called granular noise. So we discuss individually both the quantization error. When the slope of modulating signal MT is far greater than the slope of quantized signal MQT, then there occur a slope overload error as shown in figure. Here the slope of modulating signal is dMT upon dt and the slope of quantized signal MQT is delta upon Ts or delta Fs, because sampling frequency is inverse of sampling period Ts. Now, in order to reduce slope overload distortion, the maximum slope of modulating signal must be less than or equal to delta Fs. And this is obtained either by increasing step size delta or increasing sampling frequency Fs. Second quantization error is called granular noise. The reason for granular noise is that when the amplitude of modulating signal MT remains constant for a period of time t, in this situation the quantized version MQT is hunting above or below the modulating signal MT. And this hunting process introduces a granular noise. And in order to reduce this granular noise, step size must be as small as possible. But when delta reduces, it will increase the slope overload error. Also, to reduce slope overload distortion, step size must be increased, but this will again increase the granular noise. Also, bandwidth increases as the sampling frequency increases. Now, there is a requirement of modification in delta modulation technique. Delta modulation is also called linear delta modulation. In this standard technique, when delta increases, granular noise increases, and when delta decreases, slope overload error increases. And these are called quantization error. So we choose optimum step size delta in order to minimize average power of quantization error. And for the proper functioning of linear delta modulation, two requirements must be fulfilled. First is DM must accommodate a wide dynamic range, and for this delta value should be large enough. And second is, for accurate representation of low level signals, we take a small value of step size delta. And accordingly, the step size delta have an optimum value, neither too large nor too small. And we move to some adaptive scheme that is called adaptive DM. In this adaptive scheme, step size delta is controlled or vary according to the incoming modulating signal MT, and this is performed by integrating modulating signal MT before performing delta modulation. This modified adaptive scheme is called delta sigma modulation. There is an advantage of using integrator in delta sigma modulation technique. First is, the low frequency component of modulating signal MT is pre-emphasized, which means increasing the amplitude of low frequency components. Second is, in sampled signal MNTS, correlation between adjacent samples increases, and this will increase the overall performance by decreasing the average power of error signal at the quantizer input. And using the integrator, the receiver designing becomes simple. The block diagram of delta sigma modulation is shown in figure. Here, transmitter consists of integrator 1 and 2, comparator, pulse modulator and pulse generator. And receiver is simply a low pass filter. Initially, the modulating signal empty is passed through first integrator and then comparator. Comparator compares the output of integrator 1 and 2. And the output of comparator is applied to pulse modulator block. Pulse modulator block consists of hard limiter and a product modulator. At the output of hard limiter, we get amplitude level -1 correspond to negative input and +1 correspond to positive input. The product modulator multiply the hard limiter output and the pulse generator output. Here, the pulse generator generates a pulse at a sampling rate Fs greater or equals to twice of Fm. And we get the sampled version of limiter output, that is called 1-bit encoded pulse. And this is transmitted through the channel. Here, the use of integration at the transmitter side requires differentiation at the receiver side. But the first integrator gets cancelled by second integrator and there is no need of differentiator at the receiver side. So the receiver designing becomes simple, and by using a simple low pass filter, we can demodulate the original baseband signal. This is shown in second block diagram after reduction. Here the comparator is shifted toward left of the first integrator. And there is a cancellation of both integrator and make a unity feedback. So there is no requirement of differentiator at the receiver side. In delta sigma modulation, a smooth version of 1-bit PCM data is generated at the transmitter side. Smooth version means output of the comparator integrate before quantization. That is shown in second block diagram. And the hard limiter in quantizer generates only two representation level, that is plus minus delta, and called a 1-bit PCM data.